Hello all, okay, so we have a GTX 1070 EVGA FTW. As you can see, I've already taken off the cooler. We just have the bare card. I've looked at this card briefly, and I kind of want to go through what you would do in this particular case to fix this particular card. So, first let's try to turn it on. Let's see what happens. Okay, so let's turn it on. Okay, I already checked that it's not short on 12 volts, so we don't have to worry about it catching fire or anything like that. But I can tell you that when you plug it in with the cooler, the fans don't spin, but the LEDs light up. Like the fans, they don't even twitch. Okay, so that beep means that there's no graphics card detected. So if we check, let's say, our GPU V-core, we get nothing. Memory would be nothing as well. No surprise. Let's check 1 volt. A few millivolts, nothing, basically nothing. Check 1.8 volts. Again, a few millivolts, nothing, basically. And then 5 volts. Hold on, nothing. So, we don't have any voltages whatsoever on any of the rails. So, let's just check we have the base rails, the power rails that supply either by the motherboard or the PSU. So, we have 12 volts. Yep. Both connectors. Yep. We also have 12 volts in the PCI Express. Yes. And finally we have 3.3 volts. Or not. Oh, yep, there we go. 3.3 volts. So, the thing to pay attention to on a graphics card like this is that you want to know what order the voltage rails turn on. So we don't have 1.8 volts, we don't have 1 volt, we don't have GPU V-core or memory or 5 volts. Now, for this particular card, I actually don't know the order. But I can tell you that on a Asus GTX 1070 Dual, the order is that assuming everything is good, fucking hell. So if everything is good, what happens is first 5 volts will turn on. 5 volts is here on this card, and then 1.8 volts will turn on. Once 1.8 volts turns on, the PCI Express 1.02 volts will turn on, and then hopefully both the GPU and the memory VRM will turn on, and that's about 0.6 to 0.8 or 1, I should say, 0.6 to 1 volts on the GPU V-core, and 1.35 to 1.5, I think, for the memory. So, as we can tell, we don't have 5 volts. So, right off the bat, this is the first thing we want to check for. In fact, actually, let's just check if it's short to begin with. So, going to resistance mode, let's see. Okay, so just keep cycling, whatever, we don't care. So I don't think it's short. It's like I said, yeah, it's not short. As far as I can tell, nothing is short. Yep, not short. This will of course register as short even though it's not. That's just how the GPU V-core is. 1.8 volts, not short. Again, we have 12 volts with 3.3 volts, so nothing to look out for there. And of course, PCI Express is not short. Okay. So, the first thing we want to pay attention to is the 5 volts, why we don't have 5 volts. This is assuming that this is supposed to be the first voltage rail that turns on. So I'm going to turn off the video, I'm going to briefly look at it, and then when I figure out why it doesn't turn on, I'll come back with the necessary information. Okay, a little more progress on the card. One thing I've noticed with this card is that even though the 5 volt buck converter didn't read as being short to ground, if I take a power supply and I add 1 volt and add 1 volt to the buck converter, what will happen is it'll start taking in 0.3 amps. So right now I've got this lead is hooked up to my power supply. If we look at over here, we have 1 volt, 0.33 amps. So this would kind of suggest that the 5 volt buck converter is short to ground, right? But in this case, that's not actually true. You see, what's happened is I'm not sure you can see, but basically this buck converter, god damn it, see, this buck converter it has an enable pin and a VCC pin. The VCC pin is the it's the one just above the one on the bottom right. It's that one is short to ground and it's supposed to be 12 volts. So what we have is that we have a probably either this chip or a capacitor of some sort is short to ground on the 12 volt rail, and that's why this buck converter doesn't output 5 volts. Okay, as you can see, I've taken the buck converter off. The thing to notice, okay, there's two primary pins we want to check out. First is this pin over here. This pin, on the left, second highest, is the enable pin. Now, I've already checked this particular pin, and we get 3.3 volts, so we know everything's good. The other pin we want to check is actually this, on the right, the second highest. Sorry, no. From the bottom, one above. So, this particular pin. This is, as you can hear, it's short. It's actually supposed to be 12 volts, but if we put a probe on, we have a beep, and that means that we're short on 12 volts. That's why our buck converter doesn't turn on. So, for this particular buck converter, there's actually only one capacitor connected to that 12 volt rail. And if we flip the card over, we'll find that the capacitor in question is actually, if we can get if it'll focus, there we go. It's actually this capacitor over here. So if we go onto one side, beep, and of course if we go to the other side, we have it beeps again. So what I'm going to do is I'm going to take this capacitor off. I believe this is the only one, and we'll see if it's still short. Okay, so I've taken the capacitor off, and let's just check if the our short still exists on both pads. So going over to this pad, we have that beep, so it is still short, and then going over to this pad, and it's gone. So we have the source of our short. So I guess we can now definitively say that the capacitor itself that was installed on this pad was short, and at the very least, it would have, assuming everything else worked, it prevented the card from starting. So we're gonna put I'm not gonna put the capacitor back on just yet. But what I'm gonna do is I'm gonna put a buck converter on to the other side, a nil one, and we're gonna see if the card works. And if it does work, if it boots up, I'll reinstall the capacitor and we'll test it. Okay, so we changed the buck converter. I haven't put the capacitor back on yet. I just want to see if it works before I do that. So let's try to start the card and let's see if it functions. Okay, so the thing is on. Unfortunately, that beep on my motherboard means that the graphics card is not detected. If we check checking the 5 volt inductor, oh, we only have a few millivolts. So again, I know we have the enable signal, and the buck converter is brand new. I'll link the buck converter's model in the description. I can't remember the name off the top of my head. So let's just check the 12 volt rail, or not 12 volt, the 12 volt power source for this buck converter. Oh shit. So as you can see, we don't have 12 volts. We have 3.13 volts. Now, as for what's happened, my guess is that when that capacitor on the 12 volt rail shorted, it pulled so much current that a resistor or a transistor before it got damaged in the process, and now it can only pass through 3.1 volts or whatnot. So most likely than not, I'm gonna have to just trace around, and when I trace around, I'll show you what component is damaged. Okay, so I've mapped out the voltage in pin of our 5 volt buck converter, and as it turns out, it maps to a 0 ohm resistor over here. Hold on, R987. Now, I've checked the resistor. Despite the fact that it has a very clear 0 on it, and it's supposed to be 0 ohms, the resistance is somewhere in the ballpark of I think it's a couple thousand to a couple milliohms, but it fails a basic diode continuity test, and so we know that it's bad. I'm gonna replace this 0 ohm resistor, and we're gonna see if it works. Okay, so I've changed the 0 ohm resistor with a working one. Let's see if the card boots, and if it doesn't, at least if we have 5 volts. So first things first, we do have 5 volts. We also have, wait, never mind. We have 1.8 volts, and much importantly, the card works. So I guess we have all the voltages we need. We don't really need to check the others, but actually, you know what, why the hell not? Yeah, that looks good. 1 volt, yep, memory. Yep, that's fine. 1.35. Let me just turn it off before it overheats. Okay, so everything looks good so far. I'll stress test it later. The lesson you want to take from this particular card is that the order in which every voltage rail turns on matters. Now, when we got this card, we didn't have voltage anywhere except for the base voltages supplied by the 12 volt PCI Express connectors and the 3.3 volts you get from the PCIe slot, right? So now we didn't have, like I said, we didn't have 5 volts, we didn't have 1.8 volts or 1.02 volts or the GPU VRM or memory VRM, right? Now we could have wasted our time, focusing on 1.8 volts or 1.02 volts or even the GPU VRM, trying to figure out why it didn't turn on. But we suspected that those were all symptoms and that the root cause was the fact that the 5 volt buck converter didn't turn on. And the reason why at least I suspected that was because I know from experience that on a Strix 1080 Ti and on a GTX 1070 Dual by Asus, if 5 volts is missing, everything else is missing, except for, of course, the power supplied by the PCI slots and the external power connectors. So just to recap, the correct order on an EVGA GTX 1070 FTW is once 12 volts and 3.3 volts is all present and good, 5 volts turns on, and then 1.8 volts, and then 1.02 volts, and then the GPU VRM and memory VRM. Just again, to recap further, the reason why, so what we changed was, okay, firstly, I checked off camera. Okay, so what we checked on the 5 volt buck converter is the enable pin and the voltage in. The enable is supposed to be 3.3 volts, and we had that. And then we checked the voltage in, which I know from another card is supposed to be 12 volts, but that was short to ground. So, okay, this one was a bit amusing. If it's supposed to be 12 volts, then in theory, either one of these two connectors or the PCI Express slot that supplies 12 volts, those pins should be short to ground, right? But it wasn't. So this was short, the 12 volt voltage in was short to ground because the capacitor on the other side of the PCB was bad. I'll put that back on later. And the reason why we didn't see it as being short to ground was because a 0 ohm resistor was no longer 0 ohms, and the short was after the resistor and not before. So yeah, it's a bit of an interesting card, not too difficult. It's actually I'm actually kind of relieved at how quick it was. If you have any questions or you need any help, feel free to leave a comment. I don't really know if I'm going to be making a lot of these videos. I will definitely read the comments from time to time, though. So again, if you have a broken card and you're stuck, leave a comment or just whatever. And if I happen to see it, I'll try to give you an answer. Otherwise, thanks for watching. Maybe I'll see you in another video. Maybe.